Hello friends, today I will show you how magnetic lines of force are formed when we put iron filings on the magnet. I will show you how magnetic lines of force are formed in case of different types of magnets. Here you see there are different types of magnets. You see there are bar magnet. You see these are the bar magnets. This one is the bar magnet. This one is the horseshoe magnet, right? And this one is also is horseshoe magnet. This one is U or horseshoe magnet, this one, right? And this is a cylindrical magnet. This one is circular magnet. You see this is circular magnet, and this is also a circular magnet, and this one is circular magnet with a hole in it, right? I will show you the different types of magnetic lines of force in different types of magnets. First of all, let us take with the help of bar magnet, right? Let us take the help of bar magnet. We are taking here, these are the keepers. There is a plastic here. Let us take the bar magnets. Here we have taken a bar magnet here, and let us put it on the paper, and you see this is north south direction. We put it, and we put a plastic or cover on the bar magnet so that we can pick out the iron filings very easily, right? Now let us find how the magnetic lines of force are formed on a bar magnet with iron filings, right? Here you see this is the bar magnet. Let us put the iron filings and see how the magnetic lines of force are formed in case of bar magnet. You see there are many iron filings. I will put the iron filings on the bar magnet and see how the magnetic lines of force are formed. Here you see that all the magnetic line of force comes from North Pole and goes to the South Pole. And from this here also you see how the magnetic lines of force are formed. Right? From here to here you see these magnetic lines of force. You see how the magnetic lines of force are formed. From it starts from North Pole and ends on South Pole. You see this one. You see, it starts from North Pole and ends in South Pole. In this way, the different magnetic lines of force can be drawn with the help of these iron filings and iron bar and magnetic bar magnet. You see, these are the very exact, clear picture of magnetic lines of force. And you see here also that the magnetic force is more at the pole than at other places. Here you see, magnetic attraction is more at the poles, North Pole and South Pole, than at other places. And you see, these are the magnetic lines of force. It comes from north and goes to south. Here you see. Here also you see very clearly that it starts from the North Pole and goes to South Pole. In this way, you can draw the various magnetic lines of force also in case of bar magnet. This is a clear picture of magnetic lines of force. Now we will again take another magnet and see how the magnetic lines of force formed. Right? Let us take another magnet. That is, if we take a horseshoe type of magnet, let us see what happens. Here this is the north-south pole bar magnet. If you take the north-south, here see, this we have taken the bar magnet as horseshoe type magnet, and let us see what happens in this case. Let us see what happens in the case of horseshoe type of magnet. Here also you see that the maximum force is on the North Pole and the South Pole, and all the magnetic lines of force come from north and goes to south. Here you see, in this way, right? All the magnetic lines of force start from North Pole and ends on South Pole. Here you see, right? Here also you see that all the magnetic lines of force start from the North Pole and ends on South Pole. Let us take another magnet, that is circular magnet, and see what happens. This is a magnet of circular magnet, and let us see what happens in case of circular magnet in magnetic lines of force. Here you see, in case of circular magnet, one point is north pole and the other point is the south pole. You see here, you see this magnet. You see this one, this magnet, this is the north pole or this is the south pole. In both these poles, you see the negative lines of force starts from the north pole, right? And suppose this is the north pole and this is the south pole. That means it starts from the north pole and ends on the south pole. In the case of circular magnet also, it starts from the north pole and ends on south pole. You see this form, the iron furnace like that. It is starting from north pole and ends on the other side of the south pole, right? This is the magnetic lines of force of circular magnets. Now I will show you what happens in the case of cylindrical magnets, right? You see what happens. I will show you what happens in case of cylindrical magnet. Here you see, this is a cylindrical magnet, right? And you see what happens in case of cylindrical magnets or magnetic lines of force, right? Let us take what happens in case of cylindrical magnet. You see, in the case of cylindrical magnets, you see this is a cylindrical magnet and one is north pole and the south pole. That means the magnetic lines of force starts from the north pole and ends on south pole. Or the magnetic lines of force starts from the north pole. Or the magnetic lines of force starts from the north pole and ends on south pole. You see, these are the magnetic lines of force. These are the magnetic lines of force, right? In case of cylindrical magnet also, you will find that these are the various magnetic lines of force. It starts from the north pole and ends on south pole. You see, in this way, it starts from north pole and ends on south pole, right? Now we'll see the magnetic lines of force in the case of circular magnets, but a hole in the middle, right? Let us see what happens. You see, this is a magnet of hole in the circular magnet, but a hole in the middle, and see what happens to the magnetic lines of force in the case of this magnet, right? You see, In the case of supermagnets having a hole, you see the multiple lines of force indicated in this way. Right? We have shown you how the magnetic lines of force are formed in case of bar magnet, in case of U-shaped magnet, in case of spherical magnet, in case of circular magnets, in case of circular magnets with a hole in the middle. Right? You see this one. And we come to the conclusion from this experiment that the magnetic lines of force, that the attraction is more at the north pole and south pole than other parts of the magnet. The attraction or the force of attraction of the magnet is more at the north pole and south pole than other parts of the magnet. We have shown you how the magnetic lines of force are formed when iron filings are added or given to the magnet, and we found that the magnetic lines of force starts from the north pole and ends on south pole. We have already shown you how the magnetic lines of force are formed. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.